Hello students. So today we will talk about the instruction set of 8051. Okay, like with the help of 8051, what operations can we perform, what instructions can we give to CPU, etc. etc. So there are approximately 1, 2, 3, 4, and 5 instruction sets which we can perform through 8051. An instruction set is a group of commands for a CPU. As I've described here, it is a group of commands for the CPU. As I've told you that instruction set is uh, just taking the just saying that what 8051 microcontroller can perform, like addition, subtraction, logic operation, etc. etc. So we have 5 different types of instruction set: data transfer instruction set, arithmetic, logical, Boolean, and bit manipulation, and program branching instruction sets. So let us look at them one by one. So first one is data transfer instruction set. The data transfer instruction set are associated with transfer of data between registers of external program or external data memory. So this transfer instruction set, this data transfer takes place or is associated with the transfer between data between registers of external program. Okay, so whatever data is in our external register or our external data memory, so the transfer between those data is known as data transfer instruction set. So for these data transfer, we can use various instructions, like I have mentioned here various instructions like move C, move VX, push, pop, XCH, XCHT, and I have mentioned their functioning. What do they do? Like move is for move data. Like for example, as we have discussed in our previous video, when we are giving a move instruction, let's say move a comma 45h. Okay, so whatever address is stored in the place of 45h, that sorry, whatever information or whatever data is stored in the address 45h, see, let's assume here is some data that will move to a. So this is the function of a. So the this is how it works. Okay, so C is for code. C is for code. And move X for external data, move for moving the external data. Push is for move data to stack. Push is for whenever we are inserting a data into a stack. Okay, like this is our stack. We have entered here one data, 1, 2, 3, and 4. 4, sorry, 2, 3, 4, and 5. Like there is a stack here, one place is empty, and we have a data element 6 here. So when we have to insert this data into our stack, then we will use the pop operation to insert this data. Okay, so this data will get inserted here and it will be stored here. And whenever we have to delete or move the data out or copy our data, we will use the pop operation. As we can use for the pop operation, we do use the pop operation and our data gets out of our stack. Okay, by the use of pop operation. XCH is for exchange data between two registers. Like as you know, there are registers from R0 to R7. So exchange of data between any two of the registers, let's say R1 and R3 or any of those, exchanging data between these two registers. This is what this function do. And XCHD, exchange low data between two registers. Lower data between two registers. Okay, so this was data transfer instruction. Now let's see arithmetic instructions. So using this instruction, you can perform addition, subtraction, multiplication, and division. As we have seen in our previous instruction, which was data instruction, we can only move the data from external to internal memory or from one register to another register. But in the instruction, in the arithmetic instruction, we can perform some instructions like addition, subtraction, multiplication, and division. And the arithmetic instructions also include increment by one or decrement by one. You must have heard in programming languages of increment and decrement. Okay, and one of the special instructions called decimal adjust accumulator. The arithmetic instructions have no knowledge about the arithmetic instructions have no knowledge about the data format, that is signed, whatever arithmetic instruction we are performing, like addition, subtraction, multiplication, or division, that does not have the knowledge about the data format we have. Like it does not concern if we have a signed data or unsigned data or ASCII code or a binary coded decimal. Okay, it does not give a damn about it. So these all operation affect flags like carry, overflow, zero in the PSW register. We will make a separate video on PSW register. Okay. For now, just remember that these operations affect the flag. So what we can perform with the arithmetic operation is addition, addition without carry. Add means addition without carry. ADDC, addition with carry. SUBB, subtraction, subtract with carry. INC, increment by 1. DEC, decrement by 1. MUL is for multiply. Div is for divide. DAA is for decimal, adjust the accumulator register. This is for decimal and this A for accumulator. Okay. Let's see our third type of instruction set, which is logical instruction set. So this instruction perform logical operations like AND, OR, XOR, NOT, rotate, clear, and swap. You must have learned about logical instruction also in our in Boolean algebra chapters. Okay, so this function helps us to perform some logical operations AND, OR, XOR, NOT type of logical operations. Okay, this instruction is performed on bytes of data bit by bit. This instruction is performed like on 1 byte, but it will be performed bit by bit, 1 bit, 1 bit, 1 bit, 1 bit, which will make it 1 byte, and data will be performed on every single bit. So the operations which we can perform through logical instructions are A and L, which is for logical AND, ORL for logical OR, XRL for XOR, CLR for clearing the register, CPL for complement the register, RL for rotate a byte to left, RLC for rotate the byte and carry bit to left, RR for rotate the byte to right, RRC for rotate byte and carry byte to right, swap for exchanging the lower and higher nibbles in a byte to exchange of data. Okay. Now let's see our fourth type, Boolean and bit manipulation instruction. So, as the name suggests, that Boolean and bit manipulation deals with bit variables. Okay, as we have seen in our previous type of instruction set, which was arithmetic, which deals in bytes, but it deals in bit variables. So there are special bit addressable area in RAM, and some of the special function registers are also a bit addressable. Special function registers, SFRs. We will learn about SFRs in our different video. Like we will make a separate video for this topic. Okay. For now, just remember that there is a special bit addressable area in the RAM and some of special function registers in RAM. Okay. So what are the types? Sorry, instructions in Boolean and bit manipulation are CLR, which is to clear a bit, set B, set a bit, move a bit, JC, jump if carry flag is set, JNC, jump if carry flag is not set, JB, jump if specified bit is set, JNB, jump if specified bit is not set, JBC, jump if specified bit is set and also clear the bit, ANL, bitwise and ORL, bitwise or CPL complement the bit. Now let's see our fifth type of instruction set, which is program branching instruction. In these instruction control of flow of these instruction controls the flow of program logic. It controls the flow of program logic. Okay, like LJMP is for long jump unconditionally, AJMP is for absolute jump, SJMP for short jump, JZ for jump if A is equal to 0. See, sorry, wait, first we will let's see all the instructions. J and Z is for jump if A is not equal to 0. CZEN for this. You can all read it and see what is for what. Okay, JMP to jump the address. See, see these instructions, whatever instructions we are reading right now, these 5 instructions. Normally, the question which generates from this topic is that define what are the types of instructions in 8051, which are these, and sometimes it may ask you that what are the instructions used in data transfer or in logical instructions. Okay, but this is not that much important topic for theory part, because this is more of a programming part. Okay, this is more of a programming part because we use like move operation or add operation in our program when we write a program for different for different things. Okay, so if you like like if you want to design a traffic light, so we will write a program for a traffic light when it has to turn red, green, or yellow. Okay, so these instructions are used there. It is not used in our theoretical part. Okay, but yes, you just have to remember that there are 5 instruction sets: data transfer, arithmetic, logical, boolean, and program branching. You just have to remember these instruction sets, and a little about which instruction is inside which instruction sets. Okay, so that's it for today's video. Let's meet in the next one.